Hey there, y'all. Today we're going to talk about how to divide polynomials. And the essential question here is how do we divide polynomials? And so that way we can do this by long division and synthetic division in order to find all of the solutions for a polynomial. So we're going to start off with some vocabulary here. Going to take you back to like 4th grade when you did long division. And just to use some vocabulary that you've learned before, we're going to take a look at this diagram right here. So when you are dividing, there are 4 major components that you need to know. The number that you are dividing is called your dividend, right? The number that you're dividing it by is called your divisor. And what you end up with is your quotient, and what's left over is called your remainder. So as you can see there, for the example, if you want to divide 19 by 3, 3 goes into 19 6 times. So 6 times 3 gives me 18, and then I subtract, my remainder is 1. So we're doing that same exact process, and we're just doing it with polynomials now. So the essential question here for this slide is, how do you divide 672 by 21? So numerical long division and polynomial long division are very, very similar, and you're going to be able to see how similar they are with the side-by-side comparison here. So the numerical long division, you would say, can 21 go into 6? And you would say, no, it cannot. But can 21 go into 67? Yes, 21 can go into 67 3 times. So you put the 3 over the 7, and then you multiply. 3 times 21 gives you 63. And I always say the phrase, you draw the line and you change your sign. You know that it's subtraction with numerical division, but it's just really helpful once we start doing polynomials if you can remember that phrase. So 67 minus 3 is 4, and then we bring down the next value, which is 2. And then we start the process over again. 21 goes into 42 how many times? Twice, so I write the 2 up top. 2 times 21 gives me that 42. I draw the line and change my signs. My remainder is 0. So 21 goes into 672 32 times. Very similar process here when we're doing polynomial long division. We ask ourselves a different type of question though. So instead of saying how many times can 2x go into 6x squared, what we like to say is, what are you going to do to 2x for it to become 6x squared? Well, we multiply it by 3x, and we line that 3x up with our other linear term here. And then we multiply. 3x times 2x gives me that 6x squared. Now, you also have to do the 3x times 1, which gives you that 3x under the 7x. So then I'm going to draw my line and change my signs. So those first 2 terms are always going to cancel out. That's the goal. And then we have 7x minus 3x gives me 4x, and then I bring down the 2. And then I repeat the process over. What are you going to do to 2x for it to become 4x? Well, you multiplied it by positive 2. So 2 times 2x gives me that 4x, and then 2 times 1 gives me the 2. I draw the line and change my signs. The first 2 cancel out, and those also cancel out. My remainder is 0. So, tying in some key concepts here right off the beginning. If you get a remainder of 0, then that means the 2x plus 1 is a factor. And that makes sense because it went in evenly. So it's really important here. If we get a remainder of 0, then your divisor was in fact a factor. So this might make a little bit more sense if we start a problem from scratch, so let's go ahead and do that. On problem number 1, we have 4x squared plus 23x minus 16, and that's being divided by x plus 5. So I'm going to put my x plus 5 on the outside as my divisor. And I'm going to have the 4x squared plus 23x minus 16 underneath. And really important here, we notice that our equation is in standard form. That is crucial before I get started here. So what I'm going to do is I'm going to ask myself, what do I need to do to x for it to become 4x squared? I need to multiply it by 4x, and I line that up with my linear term. And now from here, I'm going to distribute. 4x times the x out front gives me 4x squared. And then 4x times 5 gives me positive 20x. I'm going to draw the line and change my signs. And the first two terms cancel. And I'm going to add the 23x and the negative 20x. So that gives me 3x, and then I bring down my negative 16. And then from here, I start the process over. What do I have to do to x for it to become 3x? I multiply that by a positive 3, and I'm going to distribute that positive 3 out to the x and the 5. So I have 3x, and that would give me plus 15. And again, I draw the line and change my signs. First two cancel, like always. And then I have negative 16 plus negative 15. That gives me negative 31 as my remainder. So we would write remainder negative 31 up next to our quotient. And so now we can answer the question, what does this tell us about x plus 5? This says that x plus 5 is not a factor for the quadratic 4x squared plus 23x minus 16. Why is it not a factor? Because we have that remainder. The only way we're going to get better at something is if we practice it, so let's do another one. If you want to, you can try this one on your own. If you need to stay with us, though, just stay right here and hang. We got x minus 7 on the outside, and then we have 3x squared minus 29x plus 56. Again, we're in standard form. We're looking good. I think we're ready to rock and roll. So what do I need to do to x for it to become 3x squared? I need to multiply that by a 3 and an x. And now I'm going to distribute that 3x to the x and the 7. So that gives me 3x squared minus 21x. And you guessed it, I'm going to draw the line and change my signs. I'm going to change that negative to a positive. So the first two terms cancel out. I have negative 29x plus 21x. That gives me negative 8x, and then I bring down the positive 56. Now, I repeat the process. What do I do to x for it to become negative 8x? I multiply it by negative 8. So everything is going to get multiplied by negative 8 here. The x gets negative 8x, and that becomes positive 56. I'm going to draw my line and change my signs. Those cancel. Ooh, those cancel, so my remainder is 0. So we can answer the question, what does this tell us about x minus 7? X minus 7 is a factor for the quadratic 3x squared minus 29x plus 56 because my remainder was 0. It went in evenly. All right, and that's what this slide right here talks about. Is the divisor a factor? We've talked about this. If your remainder is 0, then the divisor is a factor. So here we can do the same thing, determine when the given divisor is a factor for the polynomial. All we have to do is divide and see what happens. X plus 2 on the outside, and then I have 3x cubed plus 9x squared plus 8x plus 4. So here we go. Let's see if we can get a little bit faster. What do I need to do to x for it to become 3x cubed? I multiplied by 3x squared. So that gives me 3x cubed plus 6x squared. I'm going to draw the line, and change my signs. So those first two cancel, and I'm left with 3x squared, and I'm going to bring down my plus 8x. And I repeat the process. What do I need to do to x for it to become 3x squared? I multiply that by a positive 3x. So I'm going to distribute that to get 3x squared plus 6x. We draw the line and change the signs. That leaves me with 2x, and I'm going to bring down the plus 4. And we repeat the process. What do I need to do to x for it to become 2x? Multiply it by a positive 2. And I'm going to distribute that out to my divisor, 2x plus 4. I'm going to draw the line and change the signs. And everything cancels, so I get a remainder of 0. So what do we know about x plus 2? It is a factor. All right. This next one is a little tricky, and it's a very, very special one. Okay? So we are going to take x squared plus 1 and divide it into the following polynomial. X squared plus 1 going into 3x to the 4th minus 4x cubed plus 12x squared. Now, guys, right here, stop. You notice that there is no linear term. So what we need to do, if we are ever missing a term in our standard form, we have to put in a 0 for it to act as a placeholder. Okay? That's really, really important here. Okay? So from here, I'm going to do the exact same process. What do I need to do to x squared for it to become 3x to the 4th? I need to multiply that by 3x squared, and I'm going to line that up over my other x squared term. So I would have 3x to the 4th, and then plus 3x squared. I'm going to draw my line and change my signs. Okay. Those first two cancel, and I'm left with 9x squared. So you notice here, we jumped over that x cubed term. Instead of bringing down the 0x, the term that's behind, right, we're going to bring down that negative 4x cubed. Since we jumped over it, we completely skipped it. That's not fair. We have to account for it. And now we do the same thing. What do I need to do to x squared for it to become negative 4x cubed? I need to multiply that by negative 4x, and I'm going to distribute. That gives me negative 4x cubed minus 4x, and I'm going to line that up with my 0x, because they're the same. I draw my line and change my signs. The first two cancel. 0x plus 4x gives me 4x. But again, I'm not going to bring down the 5. I'm going to bring down the 9x squared because that was the term that we completely jumped over that we have to account for. And then we repeat the process one more time. What do I have to do to x squared for it to become 9x squared? I multiply that by positive 9. So I have 9x squared plus, I'm going to line my 9 up underneath my 5. I draw the line, change my signs. First two cancel. I have 5 minus 9 gives me negative 4. But then I also have to account for that 4x minus 4. So my remainder here is a binomial. It's not just a number. With a remainder of 4x minus 4. So is x squared plus 1 a factor? It is not, because if it was, our remainder would have been 0. So two big concepts here, guys. We introduced the x squared in the divisor, and we saw how that played out. And then we also saw where if you're ever missing a term in your dividend, you have to put in a 0. All right, that is the end of part 1. We're going to pick up part 2 with synthetic division.